events is when they do happen, when they can happen at the same time. So if I have probability of, say, A, right, I want, again, this is or. I want to find probability of or A or B. So I have probability of A here, probability of B here, and now they can happen at the same time, so I have this overlap, right? So if I want to find A or B, that means I want to get rid of the middle. Okay, so that means I need to find the probability of A and add the probability of B, but then I need to subtract the probability of them happening together, right? So then I got to subtract the probability of them happening together. So sometimes you can use the formula if they're independent events, right, which was multiplying to find this and part of them happening together. Or sometimes you can just count up, right? So if I have a basket full of fruit and I want to figure out, okay, what is the probability of having apples of, say, probability of green or apple, right? So then I could just count up the probability of how many green things I have out of the total. So number of green things out of the total. Then I would add the amount of apples, how many apples I have out of the total. And then I would subtract how many green apples I have. So sometimes you're able to just add it all up, and you don't have to use this formula in order to find this and statement. Sometimes I'll just give you probabilities, probability of each one, and then so you got to do this formula for the independent events and multiply them together to get this and statement. So let's do an example real quick, find the probability of overlapping events. So the probability of rolling either a number, either an even number or a multiple of 3. Okay, so I'm rolling just a number on a standard number cube, so 1 through 6. And how many are even on there? So the probability of even or multiple of 3. So that would be the probability of even, which is 3 out of 6, right? And then plus the probability multiple of 3. So 3 is a multiple of 3, 6, right? 3, 6, 9, 12, 15. Those are all multiples of 3. Well, on a number cube, there's only 3 and 6, so that's 2 out of 6. And then I got to subtract the likelihood of them happening together, both even and a multiple of 3. Well, what's an even and multiple of 3? Well, that would be 6. So that's only 1 out of 6. So then I can add those up, and I get 4 out of 6, or 2/3, or 0.67 approximately, or 67, 66.7%. Right? So any of those would work. So here you got to figure out the probability of before the or and the probability after the or, and then subtract the likelihood of them both happening together, and that's the probability of an or statement. Add the probabilities separately, then subtract the likelihood of them happening together. Yep. Go ahead and do it.